Hey everyone, so today we're going to be working on Quadratics Day 2, last day of notes for Unit 3 here. And we're going to talk briefly about the ways we've solved quadratics before. So we used quadratic formula, we did the zero product property, that's right above here, that was factor and solve. Okay, and below we're going to do the square root property and completing the square. So you're going to have this whole arsenal of quadratic solving weapons after this, so you can approach any quadratic and know at least one method, if not four, ways to solve it. So first thing, square root property. This is when we have only a quantity squared, so like x plus 2 squared, or we only have an x squared. So there's not just a regular old x going on. Okay, so this would be, like, for example, here's a non-example. If I gave you 3x squared plus 2x equals 5 or something, this could not be used in the way it is for square root property because there's an x squared and an x. So I'm looking for a problem that's like that. So x squared, no other x, or something like 3 times x plus 1 squared equals 6, or something of that nature. So only a squared term. So we're going to try these below. So if you didn't write those down, no worries. We're going to look at some examples right here. So we only have an x squared term. It says solve using the square root method. So first thing we want to do is try to isolate the x squared. That's what's going on right here. So, and then we're going to not forget the plus or minus. Plus or minus when we take that square root. So we're going to add 4. 9x squared equals 12. We divide by 9. I suppose I could rewrite this. Actually, I might leave it. I'll show you why. 12 ninths. We'll leave it like that for a second. And what we're going to do now is take a square root. When you draw in the square root, okay, you need a plus or minus. So plus or minus. And remember, when we take the square root of a fraction, we can do the square root of 12 over the square root of 9. So you can see why I chose to not simplify it, because instead of rationalizing, now I just get to do plus or minus. This would be 2 root 3, and then divided by 3. Okay, now, of course, if you had done x squared, I'll just quickly show you. If you had done x squared equals 4/3, take the square root, x equals plus or minus 2 over root 3, you would have had to multiply by root 3 over root 3 to get that same answer. So, easy either way, hopefully. And again, what happened there is we isolated the x squared term by itself, got it all by itself, take the square root of both sides, add that plus or minus, and then simplify. So let's try a couple more examples here. Okay, so we're looking at the next one. We see we have a quantity squared, so that's good. So again, similar idea, you want to get the quantity by itself. So x plus 3 squared is equal to 5. When something is squared completely, technically you could like FOIL this out, etc. But since we want to do the square root method, we want to keep it this way because that whole thing squared is x plus 3. And this is equal to plus or minus root 5. Because again, I took the square root, I created it. Therefore, if I take a square root, I need to add positive or negative root 5. And your last step here would just be subtracting over negative 3. Typically, we write the rational plus or minus irrational, but it's okay if not. And that is it. Again, we're keeping our answers exact. Technically, we have two answers here, negative 3 plus root 5, negative 3 minus root 5. On your calculator, you could get those two decimals, plug them in and check. But if we're not using a calculator, which could happen, and we should be able to do this without one, those are just our final answers. All right, let's try one more here. So, biggest mistake people make here is they try to like square root each thing. Okay, that is not something you can do. You cannot individually square root pieces of a polynomial or pieces of an equation. You can square root both sides completely, but that's why we want to try to get as much as possible that square root, or the squared term or quantity squared by itself. So we're just going to do some solving here. We get x plus 3 squared equals negative 16. We divide by 4, again, because we want x plus 3 squared to be by itself, and it's equal to negative 4. Now again, I know it might be new in your mind still, but when we take the square root, you might be tempted to say no solution, but you guys know imaginary numbers now. You're becoming experts at it. So we get x plus 3 is equal to the square root of negative 4. Again, this is the same as I root 4. And this should be plus or minus. Is plus or minus 2i. Plus or minus 2i. Square root of 4 is 2, and square root of negative 1 is I. And like I mentioned before, typically we write this as real plus or minus imaginary, a plus or minus bi. But it's okay if you write it differently. I would just say that is the standard form that you should try to get used to. So take a look at those three. Again, that was called square root method. Okay, it's a way of solving that if we have only a quantity squared or only x squared, that we can just take the square root of both sides. Now we have three things. We have quadratic formula, factoring, or square root property. Last one here, completing the square. You may have done this in Algebra 1, and basically what we're going to try to do now, we saw how nice and great this part was. We're going to try to force some other problems to be in this format and see if we can use square root property more often. Like, can we force other problems to look like that? So let's try this out. Now, all my directions are over here. Okay, so I'm going to talk through them. And then if you guys want to, need to refer back, you can. So very first thing, x squared plus 8x plus 17. What we're going to do here, okay, is we are going to start out by saying get rid of this constant onto the other side. So it's going to be subtract negative 17 from both sides. Okay, and we want to add a little space here. You can either draw a little square or just draw a blank space. And we want to recreate this to be some type of problem or some type of polynomial that factors to this. Okay, so you want it to be like x plus something squared so that we can square root both sides. So how do we pick what goes in this square? So what we're going to do, it's going to be b divided by 2 squared. B divided by 2 squared. And we're going to have to send it to both sides because we can't just like randomly add a number to one side and not the other. So b over 2 squared in this problem, 8 is b, so 8 over 2 squared would be 4 squared, which is 16. And again, if we add 16 to the right, we have to add 16 to the, left, then we have to add it to the right. Now, what was the point of that? Well, I'll tell you. The entire point of this is right now, I'm going to ask you guys, factor x squared plus 8x plus 16. So factor that. I hope you're thinking x plus 4, x plus 4. Well, we could write that as x plus 4 squared. So some people get confused and they're like, where did this go? We didn't change it. We just rewrote it as factored form. So x squared plus 8x plus 16 is the same thing as x plus 4 squared. Okay, that is equal to negative 1. It's negative 17 plus 16. And now, instead of doing quadratic formula, which is our only other option up here that we knew about, it doesn't factor, so we would have had to do quadratic formula. Instead of that, now we can just do a quick little solve. We get x plus 4 equals plus or minus I squared of negative 1. So x is equal to negative 4 plus or minus I. And that's what we would also get from the quadratic formula. So this is just, again, a different route that we can take, and I think it's a really useful one. We're going to need it later on in the year as well, so definitely make sure you feel comfortable about it right now. So, again, those steps were, they're right here. X is on one side, we moved negative 17 over. Factor out a lead coefficient. That's going to come up in the next problem here. We're going to add a blank to both sides, meaning literally a blank or like a square. I added a square. We're going to complete the square by adding b over 2 squared to both sides. We factor, and then we solve using the square root property. So there's your steps that we just did. Okay, now, you'll see we have two problems left. I'm going to just do one of them. Okay, this problem below, you can see I changed it, and we'll do it in class, so don't worry about that. I want to look at this one, though. Now, for this to work, okay, completing the square, we need either stuff to be factored out like this, or we need it to be x squared, where a is equal to 1. So I look at this problem, though, and even as I start it, I know I'm going to move negative 12 to the other side. I have all positive numbers, so I encourage you guys to divide the entire thing by 2, which is something you can do. I get x squared minus 3x equals negative 5. Okay, and I'm going to move this around a little bit. Now this one's a little bit annoying, but I will show you what we're going to do here. So here's what happens. Okay, we got rid of the 2 because, again, we divided both sides by 2, which is definitely a legal math move. And if we can't divide both sides by 2, which is something like what's going to happen in class, I'll show you another way to do it. So we're going to still add something to both sides. And the only reason this problem's a little bit tougher is now, remember, in this box here, I'm putting b over 2 squared. Okay, and b here is -3. So it's just a little bit annoying, but it's not the end of the world. -3 over 2 squared would be 9/4. Oh gosh, I need more space here. 9/4. Okay, so we add 9/4 to both sides. And again, after that step, we're supposed to factor. So if you look at this and you're like, what 2 things multiply to 9/4 and add to -3? I'll kind of ruin it for you guys. It's basically whatever b over 2 was. That actually happened up here too, right? B over 2 was 4, so I had x plus 4. So before you square it, that's actually giving away what goes right here. Okay, what 2 things multiply to 9/4 and add to -3? Well, -3 halves plus -3 halves would give me -6 halves, which is -3, and -3 halves times -3 halves gives me 9/4. So it fulfills both of those properties of factoring here. It's just kind of strange. Obviously, we don't typically factor with fractions. And then -5 plus 9/4. Why don't we write this as -20/4 plus 9/4? Again, I can do that because I'm just changing the -5 into a denominator of 4, and I get -11/4. And so would I pick completing the square for this problem? So far, I would say probably not, because honestly, I think maybe quadratic formula would have been easier, but we're going to continue on because we can do this. So we take the square root of both sides. We get x minus 3 halves equals plus or minus, don't forget, I root 11 divided by square root of 4 is 2. I add 3 halves over, and here's what I end up with, guys. And you could even rewrite this as 3 plus or minus I root 11 over 2. That looks a lot like something we would get from quadratic formula, right? Very, very similar to that format, which is because that's what you would get. It would get you the same answer. This is just another method of getting there. Okay, so was this the easiest route? Probably not, but we might as well see a different route that we could use completing the square. If you super understand it and you're feeling great, then you can avoid quadratic formula by using completing the square, which is kind of nice. And either way, it's something we're going to have to know for this chapter because I want to expose you guys to how to do this and make sure you feel comfortable with it. So again, I want you to go through those steps. Definitely retake a look at this first one. That's the steps you should truly understand. These are the same steps. We just had some fractions, right? So it's just a little more fun. We added a little sprinkle of excitement there. And the last one, I'm going to change that tomorrow, and we'll try one more in class. So that is it. Thank you guys for watching. Again, we did square root property, completing the square. Make sure you feel okay about these steps, and bring in any questions.